Some causes and considerations for these type of pollutants is inadequate ventilation, not enough. Okay? So that's why the balancing reports, when you finish and you top out a building and you turn it over to the facility manager or the building owner, balancing reports are going to be incredibly important because they'll come in and actually balance every diffuser at that particular CFM. And the reason for that is adequate ventilation. They'll also do it under return air. They'll also take particulates, especially if it's a hospital or maybe a bioresearch facility. So some of those requirements are going to be what? Conditions of the specifications by the contract. Construction. Okay? Poor filtration systems. How many have changed their own filters at the house? Okay? How often do you do it? Once a month or depending. Right? Sometimes you may do it sooner than that. How many times do you actually look up at your return air vent as you walk underneath it, as you're making your milkshake? Do you sit there and stare at it? What? You don't? Facility managers always do this. Before we even take out the salad dressing, you look up at that return air. Says, you know what? I get some particulates here in the corner. You know what? I'm going to put the dressing back in the refrigerator. I'm going to go get an extra filter, and I'm going to do it now, right? Part of a PM. You know what? It's a part of our DNA. Now, do you ever see those little dark particulates, the dirt that's coming out of your vents? And you think, oh my gosh, my duct's dirty. I'm going to call that duct cleaning place when I get home tonight, right? Part of that's static. That means your air conditioning system is not balanced properly. So as the air flows out, it has electronic charge, right? So what it does is it coagulates those little particles, dust particles. And that it looks like it's just that black film, maybe on the side of a wall next to the vents and so on. That's what that is. That means that your air conditioning system is not balanced properly. And it could happen here too. I'm looking at these vents, and actually they probably have a pretty good janitorial staff. Because typically you'll see that little ring around it. And of course, for you and I, we walk in, oh my God, this room's dirty. I'm sick already, right? No, what happens is I'm dumping a lot of air out of this diffuser, and it should be balanced. Because if you look at this one and you look at this one doesn't have anything. But then you look at your cold calls. This place over here has more calls than this particular one here. So those are just some telltale signs, okay, within the facility. Unacceptable mechanical systems hygiene. Now this is above the diffusers. This is up in what? Your ductwork. This is up at the air handler. Has anybody ever looked at water pipe? Domestic water pipe? Has anybody ever seen the inside of a domestic water line? How do you think it looks like?
I think it's pretty dirty.
There's things in there you don't want to know about, right? And you know what? But it's fresh water. It's coming from what? The city, and it's tested and inspected. But water flow for so many years going through that pipe, it has, gosh, who knows what has in it. But again, there's coagulants. And part of that's, a lot of it's minerals. You know, calciums that form inside the pipes, valves and so on. That's come at home, certain valves such as your spigots or your toilet valves and so on go bad, and your filters on your refrigerator should be replaced on a regular basis, right? Because again, because of the calciums and a lot of the fine minerals that are very huge in Arizona, okay? Back east, Massachusetts, Connecticut and so on, a lot of soft water. It's just natural. Here in Arizona, it's hard water. Did anybody ever notice in Arizona we got hard water if you take a shower? Really? I'm just so immune to it. It's like that drywall dust, right? It's like, oh, good, I took a shower. But then take a shower with soft water. Anybody have a soft water system? Do you? There's a big difference between the two, right? It's maintenance, again, but it's the quality of water, right? Anybody stay at a hotel, a nice hotel? Like maybe a Marriott or Hilton, soft water systems? You can tell immediately. So it's like, well, we're changing rooms because I don't want the wife to feel that, right? That soft water, because then she'll want it at home, right? Okay. Other items would be your coils, air conditioning coils. Okay. Facilities inspections, just like anything else, building assessments and conditions, you're going to review all the building's mechanical systems. So this isn't just what you can see. So that's why when you're constructing, before they put the drop ceiling in, you're conducting irregular inspections. So before we button up this section of ductwork, I'm going to go in and check that there's no, what, wrappers or burritos left in there, whatever the case is, it's got to be clean, right? Inspection doors. That's why they have inspection doors before the filter banks and after the filter banks. So I can go in and inspect. Do I have coagulants and dust? Turning vanes inside of ductwork systems. Remember we were talking about the air? Could you imagine the air turbulence inside? And you would think everything blows out, but when you look at a duct and you put it in, in a wind tunnel effect, you can see where the air picks up and where it drops off. Where it drops off is where you coagulate a lot of the particulates, okay, coming out of your ductwork. So regular periodic inspections, especially if it's been known to do that. So inspection door with a flashlight, you look in there. If it is needing attention, and then you perform a PM on it. Okay. How about condensate pans, right? Condensate here, well, January, December, we don't have to worry. In fact, we have to humidify buildings. But what happens in August in Arizona? Humidity. Okay. Do you ever see your air conditioning units at home? You ever look at the water that's coming out? Hey, look at that, my air conditioner's leaking. It's like, no, it's not leaking. What it's doing is the cold air is what wringing out the water that's coming into your home. And buildings are doing the same thing. So you look at the water that's coming out, but that water is where? It's going to, saturate on the pan. What happens after we get through the humidity cycle, say around October, and there's water left in the bottom of that pan? What happens to that water? It dries up, right? It evaporates. It's just a natural item. But remember we were talking about all the particulates in the air? So what has that water actually wringed out as well as the moisture? Dust. Particulates, right? So at the bottom of this pan, when it dries out, what happens to the particulates? Starts possibly molds and spores. But the coagulates, you ever seen pictures of a dry lake? How it all cracks up like mud? That's what happens to the bottom of these pans. So all of a sudden it stays dormant. Say you need to use the unit, right? So it stays dormant through November, say December. The heating cycle starts up again, say maybe in April. You start the unit up again. What do you think all those particulates are going to do? They're going to get picked up because they're going to be disturbed. So that's why the regular hygiene is so critical. Going through those particular pans after the humidification cycle, high humidity, and you actually wipe them down and vacuum them out. Even better yet, if you have condensate pans with strainers and filters on them. And not only that, but being able to get to the pans. So you don't have to have these wands with extensions and 90s at the end, so you can go in there and then fill that up. Okay? What happens when the drain line plugs up on a condensate plan? Okay. I'll share the story. In fact, it happened with AIS. The story of the $1 million flight damage, hardware damage. Humidifiers up in the air handlers, and the humidifiers. This is some of our best CSI work we've ever done. Okay, we got a call that and it was raining, and we got a call that we had a roof leak. So we're going, oh, must be the roof, right? So we went up in the roof, couldn't really see anything. So we started looking above the ceiling tiles, and sure enough, it's coming from the fan house. So we walk up to the fan house, and there's about 4 inches of water in the bottom of my fan house. So, you do what, 2 and 2, right? So it's like, well, where's the water? So it's dripping off a humidification, okay, a dump pan where they're dumping the water. And what they do is they cycle. So you have cartridges where they heat the water up to humidify it, and then they'll cycle and dump to clear the contaminants and calciums and minerals. What happened is that was one piece of plastic from an O-ring. The plastic was about maybe this big. It had an O-ring in it. So when we replace the canisters, you take the O-ring out, you put it on a canister, and you put it back in, and you turn it. That's what holds the canister. Hey, PM done, right? Except somebody forgot to count their plastic packages. So what's the big deal about a plastic package? What do you think happened? The plastic itself eventually wiggled its way, right, with the path of water. And I didn't have a secondary drain, just a single drain. Okay, I do now, right? So it basically went, and what's the odds of that happening? 1 in a million? So he says, there's something that clogged this up. It says, look for anything to do with maintenance. Maybe it was a bad O-ring, maybe someone dropped a piece of paper, maybe it was a spec sheet, maybe it was a piece of plastic. So sure enough, when they went through, they actually picked that little piece of plastic and it started draining. So, you think about it, that went down in the water. It actually had a lot of flight hardware that's NASA. They got wet. So that flight hardware had to go through a full QA diagnostics testing to make sure that the product okay, was still reliable, especially if it's going up on a satellite. So just for that one, I call it my 2 cent, okay, mishap, because that piece of plastic costs 2 cents to make. But what it costs for me to, not only, all the QA that I needed to do for that flight hardware, but the damage that it created. Okay. So after that, secondary drain, right? And then water sensors. The water sensors would have been, excellent items because they really record water. Once it gets up to a certain level, it tells you that you've got water on the floor before it starts leaking down onto that lower floor. Okay. So again, that's why develop a proactive maintenance program. So now when you go through those O-rings, there's a list of set of instructions. You take the packages and you put them back in your kit and you count them. Some folks say, gosh, this is so hokey, but it's incredibly important because of that reason, right? Imagine if it happened another time, same unit. Again, facilities credibility, okay? So that's extremely important. Integrated measurement, okay, activities. So integrated means that you ratchet it up. In some cases, you tie them in together. Maybe it's an item to where if you're getting too many hot calls, you integrate those hot calls with your air conditioning system. So you look at the PMs. When's the last time this unit was PM? When's the last time we checked the valves? Remember the predictive maintenance? Remember the ultrasonics and the infrareds? So maybe I've got a valve that's not actuating or it's not opening fully. So those were the integrated measurements. So I'm going to ratchet it on to identify what else could be causing that. Okay. And of course, regular re-inspections. Those happen on a regular basis. So after our humidity cycle, every air handler basically is shut down and we go through all the condensate pans and clean them out. Okay. Bless you. Okay. And then analysis of the building data. So this is the information that we receive back. Okay. So one would be the infrastructure configuration. Remember I was telling you about the ductwork and how it's configured? Identifying where's maybe some of the areas where you don't have a lot of air volume. Typically at the end of the run. Right out of the air handler, huge volumes. You won't find very much at the bottom of that duct with turning vanes. But you get further back, say 200, 300, 400 feet, the air volume at that point starts to slow down. So whatever's suspended will now start to drop off, okay, on that particular one. Okay. Renovation details and specifications. Any TIs, first thing you do is you block off the return airs. Remember the dust, the drywall thing I was telling you about? Okay. You do that, why? You don't want to contaminate the system. It's a TI, it's interior. It's not new construction. So this is going to be something that I'm going to be working in the building that's occupied. So I'm going to minimize any hazards to the occupants as much as possible. Other items is the may tape off doorways, restrict access. Okay. The types of equipment that they bring in. Has anybody ever worked, some gentleman worked in an Intel facility or a semiconductor. Those are ultra clean. I mean, those areas are scrubbed, during construction, after construction. I mean, to the utmost cleanliness, again, because of the product contamination risk. Okay. Air handlers use type design and operation, depending on how you're going to use it. I gave you that analogy that the basement used to be a storage, a records, a bunch of boxes. The air handler system in that particular one may have been a 15-ton standard issue air handler. But now we've put people in that. It didn't have heating. It didn't have reheat on that particular unit. It didn't have dehumidification or humidification. It just cooled boxes, right? Just kept that room temperature, say, to 80 degrees. But now we've put folks in there. Now we've got to look at the infrastructure. Can it support the occupants? So my construction folks in this room, you get the set of prints and you start reviewing them, right? And one of the questions is going to be, it says, are you going to upgrade your air handling systems? I see that you take in this high bay, inventory or stock room. We're going to build a mezzanine, and we're going to put 2 tiers of offices. And you ask, okay, the owner, or you ask the A&E firm, were the air conditioning systems upgraded? Of course, the answer should be absolutely, and they're going to be modified. If not, and then really I'm using the wrong application for that particular one, I'm going to have issues eventually. Okay, I'm using the wrong type of equipment and design. Okay. Heating and ventilation type and operations. Part of the commissioning. You won't believe how many times when you construct a building in the middle of July, the fuses and the duct heaters are never put in. Why? That's 115. Who's going to use a heater now, right? So we'll come back and do those after we finish, right? We finish this floor, we'll come back and put all the fuses in. Well, that individual leaves for another company, right? And the superintendent gets transferred to another job. Meanwhile, somebody says, you know what, I got to get those fuses. I got to get those fuses. They went on vacation. They come back. People are moving in. And says, oh, gosh, I remember, I'm supposed to do something, but I can't remember the age thing, right? Okay. And guess what happens? No fuses are installed. It's bought off. It's commissioned, right? Well, part of the commissioning, though, what should you be doing as part of the commissioning cycle? Running it to full heat, right? So then it's like, you know what? It's July. Let's run it to full cool. All of a sudden, December rolls around. So you go down to your thermostat or your energy management system and you crank up the heat. There's no heat. So first thing they do, you go to either the breaker or you go to the fuse box. Okay, up at your reheats. There's nothing there, right? So you plug them in. But again, this is what considered quality and rework, because now it's going to cost. It's going to cost labor to go back and do that. Should have been caught in the first place, right? Okay. Economer type and use. Now, economizers, these are what I would consider economy dampers on air handlers. Right now in the morning, it's getting nice. It's probably in the high 40s. Okay. Typically, when we hit those temperatures, not freezing temperatures because they're freeze coils, but in the lower to mid 40s, up into the mid 50s in some cases, what we'll do is we'll take all the outside air and run it through the building. So that means I will shut down my cooling coils because it's cool enough, the outside air, to cool my building down. So I'll cool the building down, pre-cool it in the morning, and then as it heats up, and then I'll start running my chill water coils, either 1 pipe or 4 pipe, 2 pipe or 4 pipe. But what I've done for that fraction of time is I've used free cooling. I use cooling from the outside. Same thing if I had a heat wave, right? Say it's been 30 degrees, and we get a heat wave of 80 degrees. You know, I'll probably make the adjustments to the economy dampers to kind of bring in as much of that 80-degree air as I can into the building and back off on the heating, save energy. Okay. Filtration systems, we talked about theirs. Air supply systems, such as variable air volume. But in that particular ones, you have different type of ductwork distribution systems. You have constant air and you got variable air. Constant air, you just really regulate the temperature within the air handler. Okay. On a variable air handling system, you regulate it with a damper. So you may have 4 or 5 offices lined up, okay, and you'll have individual dampers for each office. So they're going to adjust the temperature by the amount of airflow that comes into that office. If I want it warmer, I'll back off, choke down the air. It's the same temperature. If I want cooler air, I'll open up that damper to let more cool air in. Okay. Very simple controls, very simple ways to modulate and regulate the temperature within that building. Okay, typically office buildings. And humidification and dehumidification. Yes?
Would you consider like an ERV, an air supply system, or an economizer?
I would consider that a little bit of both, depending on the application. But in this particular one, I would probably consider that an economizer. Okay? For the fact being that I can support not only my external temperatures, but another opportunity would be to regulate. Remember we were talking about fresh air? Okay? What a better way to introduce fresh air early in the morning into a building by using 100% outside air. Okay, so those would be some excellent opportunities to do that. Not only have I purged the building between, say, 3 and 6 in the morning, but the occupants now coming into those rooms have been completely saturated with fresh air. Okay. Now, humidification and dehumidification. Okay. What's so important about those two? Why do you even need humidification, especially now? Possibly. Charges, electric charges. When you have extremely dry air, and you probably studied this as well, extremely dry air was very minimal, there's a static that comes along with that. So in some cases, depending if it's a factory or manufacturing facility, some cases are going to have specifications on the humidity levels. Okay, so in those cases there, you have to mechanically introduce humidified air, right? So here's the icon to this one here: humidification, dehumidification. Okay, humidification, I can introduce it with either water or steam. Okay, dehumidification, I'm going to take water out with what? Cooler temperatures. So as I introduce, say for instance, it's the middle of August here, and I'm bringing out the air because it's real humid outside. I can feel it. but inside the building it's very comfortable. Well, my air handler, as the air passes through my cooling coil, it's radically what? It's dropping the wet bulb across that coil down where it's saturating the air with cool air, right? Moistured air. And now you're dumping out into your condenser pan, okay? But as I drop that air temperature, it's coming out of my vents now at 58 degrees. A little bit chilly, isn't it? So guess what I got to do to that air? It only happens for a small amount of time here in Arizona. Remember those duct heaters? I can't have 58 degree right coming down into the office area. So now I'm going to heat up that air. So I'm going to reheat it. So now I'm going to raise it up to a comfortable 70 degrees or 71 degrees. So now I'm using two forms of energy. For that split second of time in that year, two systems are what? Fighting against one another. I've got a lot of humidity. I can't bring it into the building, so I'm bringing out that air by dropping the air temperature. But yet, for the occupants at the end, I got to heat that air back up. So we're very fortunate that we do live in Arizona for those particular ones. And the same thing on the reverse. If I have to humidify, I have to in some cases, wring that air out by raising the temperature. But that's why some of these energy management systems, right, and programs are extremely critical. Okay, so part of your construction process, as you get into new building construction, how you install and how you provide the maintenance requirements are extremely important. Okay. HVAC inspection, I don't know if you can see that. Can you see that? Right. Filtration system. Do you see what's here? Well, all this is dust that's coagulated on the filter. Do you think it's time to change it? Right? But actually, you can maybe say, well, I got a little bit here. I can probably go for another month. No, that's not good, right? That's not good hygiene, okay, in regards to that. So part of the inspections are going to be internal and external equipment. So this is external. This should be a given. Internal is going to be everything to do within the building, within your infrastructure, ductwork, or air distribution systems, okay? Type and installation and condition of the filters. If these particular filters plug up on a regular basis, now it's time to ask yourself, if they're plugging up or are running my, my differential air pressure, say that every 3 weeks I got to go up and replace these filters. Now you've got to look at the filtration system for that unit. It's telling you a telltale sign that either the MERV ratings are picking up too many particulates and you got to put a pre and a final filtration system in that particular air handler, or you got to change the filter systems, okay? The next item would be inspect condensate pans, and we talked about that, coils and valves, not only for contaminants in water, but for corrosion. Okay, inspecting those as well. It's pretty hard to seal a condensate pan when it's rusted through and has holes in it. Okay, so those are going to be some considerations. You can use fiber optic, video, okay, visual inspections as distribution ductwork. They've got little robots now you can put into ductwork, and you can remote control. And they got a little light, so you can actually go through and record particulate levels, see the interior side of the duct. Okay, they even have those for piping systems. If you've got, they do it a lot for drainage and backups and so on. Okay, but those are going to be some considerations. Microbial surface samples may be coming off the top of the pan or the coil systems themselves. Okay, there's only one thing about cold water and dark places is called slime. Okay, and it just seems to grow. So that's when you have your infrared, okay, systems that kill those microbes, so you don't have that. So again, another form of indoor air quality, okay, systems and equipment, okay. And then static air pressure is what I was talking before. You'll have a pressure sensor that measures the amount of air coming between the supply fan and your exiting temperature. The more this filter gets plugged up, the harder the fan is working to push that air through. So your higher your magnet helix in some cases, or your static pressure sensors will record that, telling you and sending you an alarm saying that this filter now is at 50% capacity or 40% capacity. So it sends you an alarm in regards to when it's time to go and inspect it and possibly change it. Okay. So really, maintenance, if you look at today's technology, is a no-brainer. Imagine maintenance 80 years ago. That'd be scary stuff. An elevator. Imagine going up in an elevator in a 1900 building that was built in the 1900. I think I'd take the stairs. Really. I mean, if you think about it, right? Okay.